In this lesson, we are going to look at the proof of the compound angle for cos A plus B. So let's just have a recap of what we did in the last lesson. We said that cos alpha minus beta will give you cos, then sin. We are going to write the pattern to expand, and then we are going to say alpha here, beta here, and then for this one beta and beta. And then we look at the brackets. The sign in the bracket is negative, so we will change it outside the bracket and this will become positive. So we have this so far. This is the knowledge, right? Now they are asking you to prove cos A plus B. So we are going to use our knowledge, the thing we know already, to find out or to prove the compound angle cos A plus B. So in order to do that, we need to rewrite this in this form. So we can rewrite this. We can say that cos, so there is a negative sign, so we must make sure that we write it again so that there is a negative sign in the bracket. Then we use the same rule, repeat the pattern, cos, sin, then alpha goes with 1 cos and 1 sin, beta goes with 1 cos and 1 sin, and then negative change into the positive outside the bracket. So we have to first rewrite this. Cos alpha plus beta will become your cos A minus and then minus B. This is the same thing, but we have just wrote it as in, so that it look like this. So we can use this formula or this you can say rule to prove the compound angle. So this is the first step. Now we can use the same rule. So for example, if we look at the cos alpha minus beta closely, this alpha is same as A here, then this beta, just changing the colors for you to it will be easier for you to understand, and this beta is same as this beta, and then we have this negative sign and we have this negative sign here. Now we can use the same rule, cos plus sin, and then we can use the angles in the bracket and rewrite it. So what we are going to say next is, this is equal to, let's expand this using the rule. So cos and sin, right? This is the first step we do. Now there is this alpha, 1a will go with here, cos 1a will go with sin. Now we have negative b, so 1 negative b will go with this negative b, like how the beta goes here. So in place of beta we have negative b goes here, and then 1 negative b will go with the sin. So another one goes here. Now we look at the last step is the sign in the bracket, and that is negative here, so we will say this is positive. Okay, so we can rewrite this again just to have a better explanation, that cos A and cos minus B is same as your cos A cos B, and then sin A sin B, and this will become your negative. Why? Because negative times positive will give you negative. Now we can say therefore cos alpha plus beta will give you your cos A cos B minus your sin A sin B. And hence this is proved. Now let's look at an example of using this rule, right? So we can say, let me just use blue pen here and a little bit smaller. So we can say the question that can appear in your exam is expand each of the following using the compound angle formula. Now we need to expand, right, each. So now we have now this is the positive sign. Now we are going to expand. We are going to say cos sin we are going to use this rule here, and then we are going to write our angle. So this is D, this is your D, this is your E, and this is your E, and since in the bracket we have a positive sign, this will become your negative. Another example we can use for this is your cos beta plus 30. Now again we will write cos and sin. Now we are going to say this angle B will go with cos and with sin, and then this is 30, so 30 degrees, and here with sin there is 30 degrees, and then because this is positive we will say there is a negative sign outside the bracket. Now let's look at an example with the negatives inside. How are we going to work out that? Now we have cos A minus cos you can say x. Again we will use the same thing, cos A cos x minus sin A and sin x. So this negative change into the positive when we are expanding. Now they could give you the expanded notation and they can say, okay, we have the expanded notation, now you are going to write the simplify form, or they could just ask you to simplify the expanded notation. For example, we have cos A cos B minus sin A, and we have sin B. So in order to simplify this, we are going to say that the compound angle, there is A and B, so in the brackets we will have A and B. There is a negative sign outside, so in the bracket we have the positive sign, and then we have cos. So this is how you will simplify the expanded notation. They could also give you something like cos 70 degrees, cos 10 degrees minus your sin 70 degrees and your sin 10 degrees. Please remember, if it comes out in exam, please don't use your calculator to find the values of cos 70 and cos 10 or sin 70 or sin 10 and then write the values and then simplify from there. This doesn't work like that. You need to be able to identify that this is the compound angle they are talking about, and they want us to expand, or you can say simplify your compound angle, whatever the question says, according to that. So this will be your cos. One angle is your 10 degrees, another angle is your 70 degrees, so 70 degrees and your 10 degrees, and then there is a negative sign, so we will say positive sign here. So they can also give you cos alpha plus beta, or cos alpha cross beta, or sin alpha sin beta, and then you have to work out according to that. Okay, another type of you can say more difficult or challenging question they can ask you to when they are talking about simplifying the angles, they can say that okay, now we understood the rules, how we can apply the rules. They could ask you, let's change the color because just to note that this is important. Okay, so this is cos alpha plus beta cos theta minus sin alpha plus beta, or B brackets sin theta. Now what we are going to do, so identify first the compound angle. This part, my pen isn't working. Okay, it's working now. Okay, so this part is similar to this part. We could use the same rule we have. So we can say, okay, this is cos A and B. There is a negative sign, so we will say this is positive. Right? Now, with cos, we have cos theta. This is similar to this. So we can say that plus theta and brackets close. This is how we can simplify the expanded notations without using the calculator. Or some more difficult equations they can give is, for example, they could say cos y cos y minus 45 degrees, and then minus sin y sin y minus 45 degrees. Now again, you must be able to identify different parts of this. So cos y and sin y, and cos y minus 45 and sin y minus 45. So the compound angle will simplify as follow. We can say this is equal to cos y, sin y and cos y, simplify into y. There is a negative sign, so we can say this is positive, and then this is the angle they are multiplying with, y minus 45 degrees. So we will write this as it is, and that will be your y minus 45 degrees. And this is how we can simplify the compound angles. Okay, they can ask you to evaluate different angles or special angles without using calculator. So this is another type of exam question that can that can appear in upcoming tests. So let's separate the page. Okay, so we say that let's use this. This is, you can write it quickly. Yeah. Okay. Evaluate cos 75 degrees without using a calculator. How are we going to do that? So we are going to say, okay, we can use the compound angles, and what are the two special angles that will make up your 75 degrees. So we can only use the special angles to the sum of special angle, and then we can try and solve. So we can say in case of 75 degrees, we can take 45 degrees plus 30 degrees. That will make up your 75. Right, and the 45, cos 45 and cos 30 is a special angle. Now use the compound angle formula to expand this. So this is cos 45 cos 30 degrees plus sin 45 and sin 30 degrees. Okay, sorry, I made a mistake here. This is not supposed to be plus. There is a plus in the brackets. So we are going to change the sign to negative. So this is the correct way of writing it. So now cos 45, we know this is already what it is equal to. It is root 2 over 2. Cos 30 is equal to root 3 over 2. Again, sin 45 or sin 45 is equal to root 2 over 2, and your sin 30 is equals to your half. Now simplify. This will give you root 6 and over 4 and minus root 2 over 4. And then now we can write this as one thing, and this is root 6 minus root 2 over 4. So this is how we can simplify the or evaluate cos 75 degrees without a calculator. Please remember, if they ask you to expand or if they ask you to simplify, do not write special angles and solve like this, but you need to use the formula and give them the expanded form. If they're asking you the simplify, give them the simplified form, and then that will be correct. If you start going using your calculator in questions to which states expand or simplify, then you will be marked down. Evaluate, you need to calculate. So they are saying evaluate the value of cos 75 degrees without using a calculator. So now you are going to use the compound angle and then use the special angles to simplify further. After using the rule, you can simplify using the special angles, the formula, the cos 75 degrees in this case, and then come up with an answer. Let's look at another example. So they say proof that cos 5b plus cos b is equal to your 2 Okay, so now we are going to prove that cos 5b plus cos b is equal to 2 cos 3b cos 2b. Now when we are proving the equation, we are going to split it into the left hand side and right hand side. So in this case, the left hand side says cos 5b plus cos b, and right hand side says 2 cos 3b and cos 2b. Now let's use left hand side. Okay, so we are going to say the left hand side says cos 5b plus cos b. Now we are going to write it in such a way that it matches your right hand side. So 5b we can say is same as, if we write in terms of 3b or 2b, we can say that 5b is same as your cos 3b plus 2b. So this is the compound angle for cos. Now we can write cos b as well in terms of the compound angle, and we can say this is also positive. Cos 3b minus your 2b. So we can say that 3b minus 2b is just b. Now we can use the formula which is given in our exam sheet. The cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta, and we can write this expanded form in terms of that. So we can say this is equal to your cos 3b cos 2b minus sin 3b sin 2b Now for the minus side, right, this is let's just so that you don't get confused, right, I'm going to highlight. This is the expanded from the formula sheet of this. Now we are going to look at this part, right? There's a positive sign in between, so we're going to say a positive sign. Let's put positive sign, and now we are going to write this in terms of cos alpha minus beta, which will give you cos alpha cos beta plus sin alpha sin beta. So again we are going to say cos 3b cos 2b plus your, because there is a minus sign in the bracket, we are going to say plus here, and sin 3b sin now this can cancel out. Okay, so this cos 3b minus 2b is same as this, so we have expanded form for this part as well. Now we can say that these can cancel out. Minus 3b sin 2b can cancel out with positive sin 3b sin 2b, and we are left with your cos 3b cos 2b plus cos 3b cos 2b, and then we can say we are left with 2, one this one, another one this one, 2 cos 3b cos 2b. So this is we can say this is equal to your right hand side, and hence we have proved that cos 5b plus cos b is equal to 2 cos 3b cos 2b. Now next question we are going to look at says if sin 32 degrees is equal to k, express following in terms of k. Okay, so if sin 32 is equal to k, express the following in terms of k. So we have first cos 58 degrees, and for option B we can say we are going to use cos 62 degrees, and then we are going to solve for it. Now okay, now this is important questions for question for exam, right? And to solve these type of questions, the first step we can do is to draw a rough sketch, right? So let's draw a sketch. There is this. there's a right hand quadrant, and there's the small triangle, and this is y-axis, this is your x-axis, and then in the standard position this will be your 32 degrees, and other angle in this case will be your 58 degrees. So now what was given was the sin 32 is equal to k. So sin 32 is equal to k, and if only k, so we can also say that k over 1, sin 32 is equal to k over 1, and if there is no k, we can also write it in terms of y and r. So this will be y over r, so opposite side over your hypotenuse side. So this side is your r side, right? And then we can say that r value is 1 and y is equal to k, and then we can work out the missing side using the Pythagoras theorem, and we can say that x squared plus y squared is equal to your r squared, and this is your Pythagoras theorem. Let's just write Pythagoras. Now we can do is x squared, we can make it the subject of the formula. So we can say x squared is equal to 1 squared minus y squared is same as k, so we can say y is same as k, so this will be, this y will walk towards your right hand side and will become negative, and then this is negative k squared. Now we don't want the x squared value, we want the x value. So now we are going to write the square root, and we will say 1 minus k squared. So this is your r is equal to 1, we can say r is equal to 1 on the sketch. The y is equal to k, so this is the y value, so y is equal to k, we can write k here. Let's just change the color. So it's more visible. So this is 58, right? Okay, so we said r is equal to 1, and we can say this is 1, y is equal to k, and this is your k, and now x value, this was the side of the x value. We found out that x is equal to root 1 minus k squared. Now we are going to say go back to the sum. So this is cos 58, and now we have worked out all the angles, so we know what is the value of the all the sides in terms of 58. So cos 58 we say equals sin 32 So cos 32 is same as your sin 32. Why? Because they are the co-function, and we can say that cos 58 is equal to sin 32 and sin 32 is equal to k over 1. So we have expressed this in terms of k. Now the B states now because this is cos 62. Now in the angle, if you look at the triangle we drew, we don't have any 62 degrees. So now we can write this in terms of compound angle, but only by using the special angle. So we can say cos 30 plus 32 is equal to your cos 62. Now we can expand this by looking at the compound angle formula, which is also given in the formula sheet, which is cos alpha plus beta, which is equal to cos alpha cos beta minus sin alpha sin beta. So this will give you your cos 30 cos 32 minus your sin 30 sin 32, and this is the expanded form for your cos 30 plus 32. Now we are going to write the values of these. Now root 3 over 2 is the value of cos 30. Now we can use to find the value of cos 32, we can use this triangle, and the cos value will be your 1 minus k squared over 1, and then we can say sin 30 value is half and the sin 32 value is k over 1. Then we can multiply this 3 into the root and we can complete the sum, and the answer we will get is so this is how we can write the cos 62 in terms of k. So this is all for proving the compound angles and looking for the sum. So please remember, for questions like this where they ask you that some angle is equal to k and we have to express those in terms of k or x or y or z, any letter they can give, and then they can ask you that if a is equal to cos 58, then in terms of k explain what will be the value of sin 32. Then you have to draw a rough sketch, fill in all the details, find all the sides, use the Pythagoras theorem to find the missing side, then go back to the question and see if there is a co-function, if there is a reduction function, or if there is compound angle. Use those and find the value in terms of the given letter. It could be anything. So this is all for the proving compound angle for cos A plus B. Thank you so much for watching.